So right now, by saying that the xi's are each 0.25, I wind up with a total pressure of 5.23. So that's not gonna work, right? Plus, we might expect propane to be much less in the liquid phase than the others, given the relative volatility. Right? Propane has a vapor pressure of 18.8 atmospheres as a pure component, right? So the idea that it's going to be 25% of the liquid phase is probably not the case. And likewise, it's probably going to be way more in the vapor, propane, than the other components, right? So now, the idea then is that, well, we've got to solve for these x's such that everything else works out. Ki is not something we're solving for, it's just a consequence of the solution. And yi is, of course, tethered to xi in the calculation. So it's really then, solver is going to be doing this for us, right? It's going to be setting this to 55 or 3.2 by changing these, and everything else is just going to fall in line, right? Subject to the constraint that, of course, these equal 1. So let's go ahead and fill out the rest of the spreadsheet and everything. Maybe we will get done with this today. Figure out what to do on Wednesday. But we could do 8 components. No, I mean, it's no different, right? 4 is enough. So L times xi. And V times yi.
Don't you need to make it static?
Yeah. I do. And those sums also have to work for us. Right, so as of right now, that doesn't work, right? So L and V are more than what we put in, right? So that also has to work, so we have to check that as a constraint as well, right? So this also has to be satisfied, is that L and V have to be equal to 100, right, as part of the split. And again, we may have to go through this twice because L and V, well, we can probably solve this without thinking about the L and V values. But let's go into solver. So we're going to go to data, solver. All right, so our objective then, on the first pass is this, right? That xi p star I is equal to a value of 3.2. And which cells are going to change? Well, for here, we're just going to change the xi's, right? Subject to the constraints, and I'm going to try this, that these cells are greater than or equal, and I'm going to put a small value, right? So if I put 0, it actually allows Excel to exclude something like no name, right? So if something's not very, I should say, in this case, propane in the liquid phase, right? You can say, well, if I don't put any propane in the liquid phase, that's fine. I can solve this, right? Because it's so volatile, it might just be easier. So let's just say that there has to be 0.001 of each in the liquid phase. And then let's add another constraint that these cells have to be less than or equal to 2.999. So it can't solve it such that there's pure of one substance or the other. And make unconstrained variables non-negative, That's fine, but we need to add a cell too, that this cell has to be equal to 1, and that may or may not fail, right, because it might get close. We may have to constrain it twice and say if you can get to 0.9999 and 1.0001 or something like that, that it'll be okay for us. So we'll just set that as it is now. Everything else should fall in line based on that. F and V, we'll deal with this later. So it says it found a solution. And so it did. Looking at this, and that's for the feed, right? So it happened so quickly, you didn't even notice it. I actually can't undo that. So there's our solution, as it would be. So on first pass, again, because we haven't solved for L and V or psi at this point. What do we have? I mean, what is this telling us, at least? It's telling us that obviously at 3.2 atmospheres and equimolar compositions in the feed, look what happened, right? There's not so much of the propane in the mix in the liquid phase, right? So the propane is only 0.138 in the liquid phase, and it represents 81% vapor. So actually, things don't change all that much, right? For the rest, right? So propane, it's lost, like half of it's lost from the liquid phase, but the vapor phase is almost all, or 80% propane, 16% pentane, so 98% of the vapor phase is propane and pentane, right?